Okay, I said I would come back with calculating cross products, but no, we want to do some cross product properties. One, first, A cross B is perpendicular. You might hear me say the word orthogonal. Same thing. You might see me use this notation to both A and B. Okay. Second, the magnitude of A cross B is equal to the magnitude of A, magnitude of B, times the sine of theta. Okay, so what this gives us is, let's say we have A and B. Okay, what we can do is we can actually say that we can construct a parallelogram. Okay, that looks like the parallelogram, sort of. And it's the area of the parallelogram. Okay, if you think about this, you could think, let me erase the inside here. Okay, if you think about this being the angle theta between them, okay, then you have, some thing here. So AB, this is A, this is B. This thing here is B sine of theta, right? Okay, that's the length B sine theta. Okay, here when I say this, this is the magnitude of B times sine of theta. So the area of that parallelogram is just this base times this height. Okay. We also have what's called the triple cross product. Okay. A cross B dotted with C, which actually comes out to be the determinant of C1, C2, C3, A1, A2, A3, B1, B2, B3. This is a volume of a parallelepiped. I can't even say that word very well, let alone write it. Okay, so what it is let's say we have three vectors here. Let's see if I can draw this. Okay, so A and B here, they're going to form a parallelogram. Okay. It shouldn't be like that. It should be like so. Okay, and then C is going to come out like so. Okay, and basically you could just make some more space. Much better. Okay. So basically, the volume of that parallelepiped is given by this triple cross product. You take the cross product of any two, and then you dot the other. And actually, that's going to work. Okay, if you take as long as you take the absolute value, because you might get a negative value if you do this, but as long as you take the absolute value, all you have to do is take the cross product of any two of them, and then take the dot product of with the other one. Okay. Okay. Three vectors are coplanar if A cross B dotted with C equals 0. Okay, what's really that telling us? Okay, so let's assume that happens. If that happens, so A cross B dotted with C equals 0, that means that A cross B as a vector, okay, A cross B as a vector is perpendicular to C, right? Okay. But if A cross B is perpendicular to C, remember that means that A and C are actually in the same plane. Why is that? Well, we haven't actually discussed this yet, but sort of going off a little diatribe here. So one of the things to sort of keep in mind, when you think about a plane, and we're going to do this in the next section, a plane is actually given by the set of all points perpendicular to a given vector through a point. I'll do all that next section, okay? But that's sort of one way to define it. So think about the XY plane. The XY plane is perpendicular to the Z axis, okay? And that's sort of a defining characteristic of it, okay? So that's where this idea is coming from. Okay. Okay, so let's do a problem. Well, let's pause and then do a problem.